So that's the original equation that will be used to find the equation of every sine graph. So to begin to find the equation of this sine graph, I'm going to write y equals sine, and then make sure to leave a space for both the a and the b, and then a space for the horizontal shift, and then leave that blank because we don't know what that is yet. So we're going to begin by looking at the amplitude. So being that this dot is at 2 and this dot up here is at 6 and the lower one is at -2, we find that the difference is 8, which divided by 2 would be 4, and -2 plus the 4 ends at 2. So the amplitude is going to be 4. And to make sure that you're correct and to check your answer, you can always count back on the top and from the point to the top to the bottom, as in 1, 2, 3, 4, 1, 2, 3, 4, and both met the ends of the graph. And next, we will find the shift right here. So the sine is, whoops, I dropped my pencil. The sine is at -0.25 pi, which will be pi over 4, which is at, so the point is -pi over 4, 2. So to add that shift, we would put x plus pi over 4. Next, we're going to find the last part, which is easy because we find that the sine point is at 2, so we know that that will be 2 because the whole entire graph has shift up 2. So to find this part right here, we're going to use an equation called PB equals 2 pi, in which we're going to have to find the amount of the distance between one cycle. So right here, from this point to this point, we know that this is half a cycle. This is half of a cycle, so it's a quarter cycle. So from pi to -4.25 pi, it's going to be over 4. It's going to be 5 pi over 4 difference. And being that this is only half of this will be 10 pi over 4, this entire distance. And being that this is only half a cycle of the graph, then we will have to times it by 2, which will leave us with 20 pi over 4, which gives us 5 pi. So we end with 5 pi, which we will replace into this equation. And then we will solve it, which will be 5 pi divided by 5 pi. And this will leave us with 2/5. So 2/5 is what will belong in between right here. As for cosine, we will do the same thing. I'm sorry, I forgot to write the top part. So it'll be just the same exact thing, just with cosine. So with a cosine graph, it will begin the same way. We know that this will be the same as the other one because it has been moved up 2. So we will add the +2. This will be the same thing also. The only differences will be, this will be the same too. The only difference will be the horizontal shift, the x on this one. So this one will be, being that it is at pi, will be x minus pi. So the last thing we're going to look at is making sure that the amplitude is positive, and if it's not, we will change it to negative. So If a sine graph were to be going up like that, going up afterwards, it would be positive, but since this sine graph is going down, it will become negative. And with a cosine graph, if the cosine graph were to have been up here, say if the dot was right there, it would have been positive. But since it is not, and it starts at the bottom, then this is also negative. So we have our two equations for this graph. We'll rewrite them. So we have y equals -4 sine 2 over 5 x plus pi over 4 plus 2. And for the cosine, we have y equals -4 cosine 2 over 5 again, x minus pi plus 2. And those are our two graphs, two equations for the first graph. So beginning problem number 2, we are going to begin by writing the same equation, leaving a space in between the sine and also the cosine. Learning from the last problem, we now know that the end shift will be the point, the y value of the sine point. So this one is at 3. Being that the graph has shift up 3, that will be the end. We see that this sine point is at pi over 4, so we subtract the pi over 4 in our x parentheses, and we see that the cosine point is at 1.75, which will then become 7 pi over 4. So we subtract 7 pi over 4. We see that it is at a 3, at the y value for the sine point is at 3, and for the y value at the cosine point, it is at 9. Seeing that the difference is 6, we add 6 to each. 1, 2, 3, 4, 5, 6 to make sure on both of them. And we see that it is correct. We see that both of the points are positive this time, so we leave them at 6. Writing our PB equals 2 pi, we begin to find the fraction that belongs here. So we see that it is at pi over 4 for the sine and 7 pi over 4 for the cosine. Seeing that it is a 6 pi over 4 difference, or a 3/2 if you want to simplify it. Sorry, I didn't see. So this is, again, half of the half, so we have to multiply it by 2, which we will continue over here. So it is 3 over 2 pi times 2, which will become 6 pi over 2, which becomes 3 pi. And being that that is still only half of a cycle, it will become 6 pi. 6 pi, replacing in our PB formula, equals 2 pi. We will divide the 6 pi again, and the p will equal 1 over 3, which will be the fraction that we put in this right here. And these are the two equations for number 2.
Moving on to number 3 and 4, we're finding the equation of the graph given to us in terms of cosine and in sine. So to start off with, we know that we're finding cosine and sine. And then we want to find the highest and lowest points of the graph. So we have the graph here start, its highest point is 2, and its lowest point is -8, which means the middle term would be -3. Knowing that the growth in between the midpoint is 5, we then know that the middle of the graph is at -3, which would go on the end of both equations. And then we have to find our starting points, which are given to us. These are dots number 1. For sine, we have -1/2 pi. So moving to the left, we put the positive, and then pi over 2. For cosine, we have 3/4 pi for our x value. Since it's moving to the right, we have -3/4 pi. To finish the equation, we need one last term, which we find by the distance between the x values. So this is half of our actual graph. So we'll start by finding the distance between the lowest and the highest point, or the x values of those points. We know our lowest point of the graph's x value is 3/4 pi, and then we also know the highest point value is -7/4 pi. We then take 3/4 and subtract it by -7/4, which gives us 10/4 pi, or 5/2. But since this is only half of our actual sine and cosine graph, we have to double that. So 5/2 multiplied by 2 is 10 pi over 2, which is also equal to 5 pi. To find the term we need, we follow PB equals 2 pi. Our 5 pi is our p value, so we plug that in for p. 5 pi times p equals 2 pi. And then we need to divide the 5 pi out to get our b, and b then equals 2/5. 2/5 then goes here, and we have our equations. We're going to follow those steps again to find the answers for number 4. So we know we need cosine and sine equations. Once again, we'll find the highest and lowest points of the graph, which are, the y values are 4 and -2, which would make our middle value 1. The distance between the middle values and the highest and lowest points would be 3. These graphs happen to be positive. We also have our middle value, which gives us our ending, +1. We use the number 1 dots that are given to us. As for the cosine, the x value is +1/2. So since we move to the right, we have a -pi over 2. To find our second number 1 dot, for the x value, we need to find the midpoint between the highest and lowest point of the graph. So in this case, we have -1/4 pi added to 1/2 pi. which equals 1/4. Then we need to find the midpoint, so we multiply it by 1/2, and we get 1/8 pi, which gives us our answer to dot number 1, and it moves to the right, so we have negative pi over 8. And of course we need our last term, so we have our highest and our lowest point. The x-hat values are 1/2 and negative 1/4. So we then subtract 1/2 pi by negative 1/4. We then get 3/4 pi and then since these are only half of the equation shown, we have to double our answer, which gives us 6/4 pi, or 3/2 pi. Now following our PB equals 2 pi equation, we can plug in 3/2 pi for P, and then we solve for our B answer. So we'd multiply the whole thing by 2, and we'd get 3 pi. B equals 4 pi. Dividing everything out by 3 pi, we'd then get B equals 4/3. This gives us our final term needed for our equation, and we have our answers to the equations.